Hi, your last lesson of Chapter 10 is about factoring higher degree polynomials. And frankly, I'm not going to teach you anything new, particularly in this lesson, because you really do know how to tackle these problems. But I am going to review some of the things that we've done so far in this chapter and just kind of show you the best way of tackling these higher degree polynomials. Now, if you've had no problem whatsoever in the first 7 lessons, and maybe a few of you fit that category, then just shut this off now. But if you would like a review, and since the quizzes and tests are coming, it might be a good idea. Then just stay tuned. Now, I basically consider that we have 4 steps of factoring. The first step that you should always look for when you are told to factor is to look for the greatest common factor, commonly known as the GCF. And sometimes that's the only factoring you'll need to do. For instance, if you had this problem, 3xy plus y cubed. Now you can see right off that they have a y in common. Okay, they look like they kind of have a 3 in common, but they don't, because a 3 coefficient is quite different than a 3 exponent. So we're going to pull out the y that they have in common, and then we're going to put our leftovers in parentheses. So y times what would give me 3xy? Simply 3x. Okay, and y times what would give me y cubed? Y squared. Okay, now I have a binomial left here. Okay, but when I look at that binomial, I can tell that I can't move on to my second step, which I'm about to reveal to you in a moment. And so there's nothing more I can do, and that is all the factoring I can do, just finding the GCF. The second step is looking to see if we have a binomial, okay? And again, even when you're given a binomial, you still need to look for a GCF. But if you have a binomial, if it's in this form where you have something squared minus another something squared, or what's referred to as the difference of squares, then your factors are going to be a sum and a difference of those square roots. Let me give you an example. If you had 3x cubed minus 27x, okay, it doesn't look perfect at this point, okay? But our first step is finding the GCF. When you look at these two, you can see they both have an x in common, and they both really have a 3 in common, because 3 times 9 is 27. So if I factor out a 3 and an x, okay, then 3x times x squared would give me 3x cubed, okay? And 3x times 9 would give me 27x if I were to distribute and check my work. Okay, now I have a binomial left, but it's different than the other binomial I just showed you. This one, I can take the square root of x squared, and I know I can take the square root of 9, and it's subtraction, so it's the difference of squares, which tells me right away that I simply have x plus 3, x minus 3. In other words, the square root of this, the square root of that, 1 plus, 1 minus. I have the GCF that I took out. I have to keep all of that together, and that is my factor of 3x cubed minus 27x. Now, the third step in factoring, and again, you should always look for a GCF first. And if you look and it's not a binomial and it's a trinomial, then you want to ask yourself if it could possibly be a perfect trinomial square. A perfect trinomial square is what we see here. X squared minus 20x plus 100. As soon as I look at it, I look at my x squared and my 100. Can I take the square root of x squared? Yes, it's x. Can I take the square root of 100? Yes, it's 10. Now, if I write those two down and I multiply them by each other, which would give me 10x, and I multiply it by 2, does it equal this middle term? Well, yes, it does, okay? And I can realize as well that I have to make it a subtraction, x minus 10, because my middle term is negative. Now, if your term is subtraction at the end, you don't even need to check to see if it's a perfect square, because it won't work, okay? And let me show you a problem that, again, you have to first look, can you take a GCF? Okay, well, what do they all have in common? Well, they all have x's, okay? That's the only thing they have in common. Well, when I pull that x out, I end up with this, okay? I pull the x out, I have x squared plus 4x plus 4. Well, let me look at my first term and my last term. Can I take the square root? Yes. Okay, can I take the square root of 4? Yes, it's 2. Is x times 2, 2x, and then doubled or multiplied by 2, is that equal to 4x? It is, and this sign is positive, so I know what sign to make my binomial, and I can simply write x times x plus 2 squared. And this is my perfect factors for this original problem. Again, find the GCF, look to see if maybe it is a perfect trinomial square. And of course, after that, we have what we lovingly refer to as the booger problem. And these are problems that don't fit those other categories. And yes, you should still look for a GCF because it's quite possible you'll have one. But in this case, I kept it simple. Okay, this is a booger problem, and it's a relatively simple booger problem. If the coefficient for x squared is simply 1, then you have the opportunity to just look at this last term, the 22, and think of factors of 22 that when you sum them together or add them together, it equals 13x. Well, you can go through your little process. 22 times 1, well, that's going to equal 23 if you add them together. You could do 11 times 2. Well, 11 plus 2 does equal 13. Okay, and so you are very easily able to find your two factors. Okay, so you take those factors, you just simply put them into this problem. Now, the last type of problem is basically a big booger problem. Okay, and I taught you the ABC method, which I really like because it's kind of scientific and it definitely shows you exactly what you need to do. Okay, and that's basically you're looking for A times C numbers, factors of A times C, in this case 15, that add up to B, which is 16. Well, I think you can probably look at this pretty easily and tell that 15 times 1 is going to add up to 16. And so you can stop right there, and all you do is you write your first term. Instead of writing 16x, you're going to rewrite it as plus 15x plus 1x, okay, and then plus your 5. And then you're going to look at these first two terms and you're going to look for a GCF, our common theme here. Okay, I can pull out a 3x and then I would have x plus 5 left. Well, when I look here, I don't really see a GCF, right? So I know that it's prime. I can just put a 1 there, okay? And then I can see that I have an x plus 5. And then you can also, whatever you get in your first parentheses is what you should get in your second parentheses. And then you just take that and you basically consider this your GCF and then these your leftovers. And so you can have your GCF times the leftovers, 3x plus 1. And now you have your factors for the big booger problem. Let's show you some other stuff that you might find. If you had this problem, for instance, you would have to look for a GCF. Okay, now I see I've got x cubed, I've got y, I've got 2, and I've got x squared and a y squared, I have an x and I have a y cubed. Now, if you look, you can only pull out one x, right? They all have at least one x and they all have at least one y, but that's all they have in common. But if I pull out that x and y, then I end up with simply x squared here. And I end up with 2 times xy here, and I end up with simply y squared here. And when I see that, then I can look at this trinomial, and I can see that I can take the square roots of both of those very easily. And if I do that, okay, and I put those square roots here, is this times this doubled, or this times 2 equal to 2xy? Of course it is. This is positive, so I know my sign, and I know it's squared. Okay, so I have found a perfect trinomial squared after removing first that GCF. Okay, now this is a very strange problem that you will see in your book. Okay, and because you've already learned how to do factoring by grouping, doing the ABC method, you're not going to find it hard because you're just going to take the terms like this and you're going to say, okay, I've got 2xy plus 6x. You're going to group them together. And what do they have in common? Well, they both have an x, okay? And they both have a 2 because 6 is 2 times 3. So we'll pull out what they have in common, and then we'll put the leftovers in parentheses, okay? And then I'm going to subtract, because these are both negative, and what do they have in common? Do they have 14 in common? I think 14 times 3 is 42, so let's pull out 14. Okay, if we do that, then we would have a y here and a minus 3, actually plus 3. Because if we pull out negative 14 and plus, I should just cheat, and I know my parentheses are going to match. Okay, so now my GCF is y plus 3, and I put my leftovers, 2x minus 14, into parentheses, and I have found my factors. Factoring by grouping, it's a delightful thing. Let's look at one more problem. If we had x to the fourth minus 3x squared y squared minus y to the fourth, it's similar to the other problem we've done. Okay, they all have x's. The most, or the whatever that the smallest one has, is x squared. We can pull that out, and we can also pull out the y squared. So if we pull out x squared, y squared, what do we have left? Oh, we can't pull out y squared. What am I thinking? I'm so brainless. That's okay. We're going to try this a different way. Okay, we have x to the fourth minus 3x squared minus y to the fourth. Just because we don't have any y's here, we don't have any x's here, so we can't pull out a GCF. However, we can do our ABC method, or in this case, we can just look at it as a booger problem. We're looking for factors of negative 4 that are going to add up to negative 3. Well, we can obviously do negative 4 and positive 1, and they do add up to negative 3 when you add those together. So we can simply just do, in this case, x squared minus 4y squared, and we can do x squared plus y squared, or 1y squared, if that makes you feel better. And that should give us what we want, okay? Because if we did FOIL, we'd get x to the fourth. If we did our inside terms, we get negative 4, but our outside terms would give us a positive. Okay, so that does add our middle term, and then we end up getting negative 4y to the fourth. So this is our factors. So I think you see that you have all the tools that you need for solving these higher degree polynomials and factoring those. So have a great time. Think, and go through the steps.